Welcome, everyone. Thank you so much for joining us today on our webinar. Good morning, good afternoon, good evening from wherever you're joining us. So this session is going to be recorded for you to access on demand later. And then what we're going to do is we're going to have a Q&A section at the end of this presentation. So you can submit your questions ahead of time in the Q&A section of this webinar. Okay, so again, welcome everyone, and thank you for joining us today. And our topic of discussion today is going to be best practices in the unified namespace design. So this session is really designed to help you think through how to design a unified namespace, how to get maximum value out of a unified namespace. So before we start, my name is Kudzai Manditereza. I'm a Senior Industry Solutions Advocate here at HiveMQ, and I also teach at Industry 4.TV YouTube channel, concepts around industrial IoT, unified namespace, and smart manufacturing. So let's look at our agenda today. And before we dive into this webinar again, I want to get a sense of where everyone is on their UNS journey, whoever is on this call here. So we're going to launch a poll, and so please do assist with your response here. Help us get a sense of where you are on your journey in the unified namespace. Okay, so let's take a look at the agenda for today. So again, as I mentioned, this is really meant to kind of like give you a full picture of exactly how to think through as you design your unified namespace, how to kind of like really build your namespaces. So I'm going to start off with an introduction into the unified namespace, just briefly going through a few slides to talk about what is the unified namespace. And exactly what it means and how does it help you sort of like get maximum value. So I could see 67% of you are in the research phase and 26 are actually doing a POC, and then we've also got 7% who are scaling out. So this is good feedback. Thank you. So again, after we've gone through a few slides to introduce the idea of a namespace, as it were, we're then going to go into a live demo, kind of like really help you sort of like visualize exactly what it means to build a unified namespace and exactly talk through the best practices of designing a unified namespace using a real sort of like live demo. So I've got a simulation that is going on here. So we're going to look at it right now. And then we're going to go through, talk about exactly how to sort of like create some categories of the namespace to represent different segments of your process. We're going to talk about how to design a namespace to hold information about your production resources. And then we're also going to talk about namespace for operations events, use case centric namespace design. And we're also going to talk about the namespaces that allow you to exchange information between your business domain and your control domain, and vice versa. How do you push data out into the business domain from the control domain, and also how to exchange data within the control domain, what you call your manufacturing operations management. So as you can see, we've got a jam-packed session here. So without further more to do, let's dive into it. So kind of like first thing that I want to talk about here is this idea of the unified namespace being a platform for sharing data and information. Now, the word sharing, I chose those carefully because this kind of like where a lot of misconception around the unified namespace is, where the unified namespace is for the most part kind of like treated as a data collection approach, or rather a data collection architecture, which it is, but that's kind of like really not where the power of the unified namespace is. The power of the unified namespace is in the ability that allows you to share information, not just kind of like collect data and check it somewhere, but rather to share information in real time across business domains, from business, control, operations, being able to share all of this data and the information, as you will see once we start to go into the namespace design. And again, the ability to share this information is through these data access points or namespaces, as it were, right? And then kind of like the other part that I want to sort of like stress here is this idea that since you are kind of like adopting this model of sharing information from the edge, from these business domains, right, through this common data infrastructure, your MQTT broker, what you then have is you have got sort of like an authoritative pool of information, because information is being published, is being prepared by domain experts from each field or from each domain, and then pushed into this common data infrastructure. So what you end up having is this pool of information or data that is authoritative and trustworthy, which then allows you to be able to build your business model around. And to kind of like think about how you would do it otherwise, it's a situation whereby information is simply collected from the shop floor. It is then, say, maybe dumped into a data lake, a data warehouse, and then you've got a different team that needs to go into this data lake or data warehouse, perform the transformations, pass this information along through this pipeline. Now, there is no kind of like trust along the process that this information was actually prepared by people who know exactly where this information or how this information should be packaged. So having this being prepared by domain experts is where also the power of the unified namespace lies. And this idea of sharing information, authoritative information, trustworthy information, then set the stage for you to be able to automate your business processes using the unified namespace. And this is kind of like really a capability that really goes unnoticed, or rather, again, as I mentioned, the focus mostly is kind of like really using the unified namespace as a sort of like a data collection framework, right? So this kind of like really doesn't emphasize the point that once you think about it as sharing information, you then are able to kind of like automate your entire business process, because you've got information moving between domains, right, through this unified namespace, through these namespaces, which then allows you to automate not only your control systems, which are already being automated, but rather all of your business processes from the time an order is received and then that is submitted to the shop floor, to the inventory. All of this stuff then gets automated as you share that information through the unified namespace. And to kind of like give you a picture again, before we jump into the demo, of exactly what that concept looks like of sharing information. So as you could see here, we've got the typical users across your OT and IT, where you've got process engineer, plant manager, machine operator, business leader, data scientist, and data engineer. These are all actors within your OT, IT infrastructure, people who have got sort of a vested need or interest in the data. So typically what would happen, for example, here you want to implement a quality prediction use case. So perhaps you're in a process where you want to be able to predict what the outcome quality would be. So I've worked in a mining environment where a process engineer would sort of like collect information and send it to a test lab, and then that would take like an hour for that information to be processed, and then they'll report back and say, this is basically where this process is going. This is how much impurities you're going to get from this batch. But to have this ability for you to be able to share this information seamlessly between different domains without having to collect this information using paper and all these kind of inefficiencies. For example, here you could have a process engineer sort of like preparing sort of like a data product or a group of parameters which they want to pass on to the data scientist for them to be able to, say, train a model. Once that model is trained and that model is now in production, the data scientists are able to also publish those predictions back to the process engineer through that same namespace. So there's this real-time sharing of information in a decoupled way where they don't really need to understand what systems the process engineer is using or what system the data scientist is using. And then when the process engineer has got some actions that they want to be performed, they can also share that information through the unified namespace for the machine operator to be able to see that information on a HMI or whatever the case may be, and then they will take whatever action. So as you could see, this is really a powerful way of being productive with data, where you're getting data to the people that need the data to perform the work that they need to do, or to be innovative about the work that they need to do. And this is kind of like a simplified example of exactly what we mean by sharing information in real time rather than just collecting data. So again, here the topic today is really about namespace design, and it goes beyond obviously the equipment hierarchy model as defined in ISA 95 part 1, but this is kind of like the basis of it, as you'll see. So just kind of like bring this picture up here so that we're all on the same page, where if we're talking about the equipment hierarchy model, ISA 95, we're really kind of like talking about this hierarchical representation of all your production assets, depending on the production type of which you are working on. Okay, so now let's jump into our demo to really start to look at what exactly that looks like. Okay, so I hope everyone can see my MQTT Explorer. All right, so what we're going to do here is we're just going to go through different phases. Well, they're not in no particular order, but rather different levels of your hierarchy, or different levels of a unified namespace definition, and kind of like see exactly how you'd be able to do that. Okay, so the first stage that I'm going to talk about is exactly what are the best practices of outlining or clarifying the physical structure of your organization. So again, as you know, the power of the unified namespace is this ability to kind of like put information in a semantically understood namespace. And part of that is really representing information in the physical layout of your organization, how equipment and sort of like whatever production material that you're using is laid out already on a shop floor, is how you want to represent it on the unified namespace. And here, the best practice, again, it's not a hard and fast rule, but a lot of work has been done in kind of like really standardizing on the ISA 95 Part 1 equipment hierarchy model on exactly how this should be structured. And in any case, a lot of companies already implement ISA 95 Part 1 equipment hierarchy model in how they're arranging their equipment. Some of them, they're implementing it strictly, or you may be having sort of like implementing a variation of it. But this is kind of like the first stage, really, of how you could outline or clarify the physical structure of your organization. So as you could see here, basically, again, as I mentioned, I've got a simulation that is running, and this information is being published to the HiveMQ Cloud MQTT broker. So what we're then doing here is we're using MQTT Explorer to pull that namespace or unified namespace down to visualize what exactly it looks like. And this first phase that I'm talking about here is this phase of clarifying, or kind of like really outlining the physical structure of your enterprise. So the example that I'm using here is for an automotive manufacturing company called Auto Industries, which has got two sites, one in Munich and another one in Berlin. So as you can see, we're looking at the MQTT topic namespace that is representing this sort of like semantic hierarchy. So you could see here we've got a root namespace that is Auto Industries, and then from there we've got these namespaces which are then used to hold information. So for example, Berlin is a namespace that is used to hold all of the information that is coming from Berlin, and Munich, all of that information that is coming from the Munich area. And then here, because these are identical, it may be the case that you don't have identical production environments, but for this example, we've got identical sort of like production types here on Munich and also in Berlin. So as you could see here, we've got the press shop area, body shop area, and the pen shop area. So for now, we're going to focus on the Munich site, because this is basically the same thing here. So as you go into your press shop area, you can then start to see that we've got a production line. So here I've got 2 production lines, again, as an example, but you could have so many more production lines under there. And then here, if you go into your production line, you can see that we've got work cells. So here I've got a forming work cell, and then I've got a cutting work cell, and then I've also got an inspection work cell, right? So here we're in the door press production line. So for now, we're going to kind of like focus on that end, because the concept that we're going to talk about from here going forward can be replicated on the different production lines at whatever site you are building the unified namespace for. So as you could see, we've gone through the first step of kind of like really outlining our organizational structure. This is basically how our production equipment is arranged. So now we're going to sort of like move into step 2 of this phase. Okay. Let's just give it a minute. Okay, there we go. So, right, step 2 now, we're focusing on, say, we've outlined the physical structure. Now, because within a work cell or within a work unit or whatever production type you're using, the next thing that you want to be able to do is to categorize that into different process segments, right? And the reason why you want to do that is because, again, this idea of a unified namespace as a way of sharing information or collaborating through this namespace is when you're looking from the business, looking down into your shop floor, basically from a logistic perspective, you want to see these process segments. Like, business doesn't really care mostly about the nitty-gritties of exactly what goes on as the work orders are being executed, but they want to be able to view the different process segments for logistical purposes. They want to know what inventory is available, or what sort of how many parts have been met at a particular process segment, and so on and so forth. So this kind of like best practice of then splitting your work cell or work unit, or in case where you don't have a work cell, but kind of like you've got a work area that you want to be able to split into ways where you've got like these different process segments. So if it could be, for example, where you're saying I'm making, you make a chair or you paint a chair and so on and so forth. These are different process segments, even though they may be sort of like in that one work area. So the next step is really, you want to be able to kind of like segment all of that information. So as you could see here, I've got a process segment, so where we're doing the pressing, and then I've also got a process segment where I'm doing the material handling. So I want to be able to sort of like create a distinction between these 2 process segments for logistical purposes. So if we go on again and see here on the cutting work cell, you see I've got also different process segments. I've got one for blanking, and I also got another one for material handling. So again, here you're doing pressing, and then you've got a robotic arm that is kind of like moving stuff around, or some conveyance happening elsewhere. You want to be able to kind of like create this distinction. And another really benefit of really kind of like creating these process segments is that you want to be able to group those pieces of equipment. So you've got, so again, to that example where in material handling process segment, you've got a robotic arm, a conveyor, you want to be able to group those related resources under that specific segment. So that's kind of like also an ISA 95 specification that allows you to be able to view all of those information, to be able to exchange information effectively between your shop floor and your top floor. So that is the phase of really defining your process segment. And here you'll notice that it's the best practice, again, to use verbs here to kind of like really define your process segment. So it's like pressing, so it's filling, it's painting. So all of these things that involve a certain unit of work that needs to be done is exactly how you'd want to be able to name your process segments within each work area or work unit. So again, we're still following that structure, that MQTT namespace, to design that unified namespace. So let's move on to, so again, one thing that I also want to point out here is that we actually have these 2 work cells that is called two different process segments. So they may not be the same at each different work area. So let's move on to the next step. Now, the next step is kind of like really where we are now starting to kind of like define the equipment, right? The production resources that are kind of like really executing all of this work, right? So this includes your equipment, this includes your personnel, this includes the materials. So this is kind of like the next step that you want to be able to bring into your unified namespace. So again, here, I will go into this specific pressing process segment, right? So you may be calling it differently. So as soon as I go into my pressing segment, you can see I've got a mechanical press. So that's my equipment. All of this information that is related to the mechanical press is then going to be sort of like contained within that namespace. So this is kind of like your equipment namespace. So we're going to look into that in the next stage on exactly what are the different namespaces that need to fall under that equipment namespace. But still under the process segment, you can see here that we've got a part. So if I kind of like click into the part namespace. So if you are in sort of like in batch manufacturing, this could be your batch. So here, well, the focus today is not really on the data model side of thing or kind of like the object modeling, but rather on the namespace, but just kind of like to show you what that part means. So for example, you've got a part that is moving from one machine to the next, whether within that work cell or across work cells. So that part would have all of this information that is kind of like really collecting data as it passes through that specific machine. So here I've got a part that is passing through this specific machine. So it has got its own namespace where I've got information about whatever part it is that I'm working on this specific sort of like process segment. So here we're actually pressing this specific part that has moved from the different paths. And then also you want to have, so we've got a namespace for the equipment, we've got a namespace for the part that is being worked on by the equipment, but you also want to create a namespace for environmental conditions. So maybe you're in a dry room, you want to monitor things like your humidity and your temperature, just kind of like some environmental conditions. So this is kind of like also where you need a namespace for. So in this segment, you kind of like see that we've got three namespaces for the machine, for the environment, and for the part as well. So if you go into your mechanical press namespace, so kind of like just at the top level, you see this is kind of like a definition of exactly what this type of equipment is, what it does, what is its capacity. This is just definitional information that is being held by this namespace, but we're then going to start to sort of like populate it with more namespaces as we go along. So same applies if we go into your cutting work cell where we've got a blanking press that is also got sort of like a part that is being blanked at this specific moment. And then we have also got an environmental namespace. So these are the most important parameters that you then want to be able to sort of like integrate into your IT or into your business domain, as it were. So now we're going to move to the next step. So the next step here is going to be, so let's see if we can get this one going. So the next step is now where we're kind of like really defining the events. Now we're kind of like really determining what data exactly that we're collecting. So up until now, we've kind of like really just been laying down the access path or kind of like these namespaces that lead to where you can then try to get all of those events. Because remember, the unified names is really about kind of like giving you the current state of your operational sort of like event, right? So you want to be able to kind of get the current state of exactly what's going on around your business operation. So here, if we go again into your mechanical press, so as you see, this mechanical press namespace that we created earlier now is being populated with information, different namespaces for different purposes. So what you'll notice, first of all, is that we've got a namespace for the state. So the namespace for the state that kind of like just gives you information about this piece of equipment. Is it operational? what is happening about this equipment? Is it currently halted, or any information that is represented of this state of this information? So here you could see it's currently operational. This is the press force with which it is currently operating. And then the other namespace that you want to build is kind of like those idle parameters. So when the equipment is not doing anything, so maybe you may want to calibrate this piece of equipment while it is being idle, or whatever data you want to collect when the equipment is idle for whatever use case, you want to be able to collect that information. So again, remember, we want to reflect the current state of the business. So we're saying this equipment is not currently operational, but this is the current state of its sensors for many different reasons. You might want to aggregate all of that information or use it in other purposes. And then we've got information about the job cycle. So, right, this could be in a batch. This also could be a cycle where you're kind of like adding a material. So a job cycle is a namespace which is really critical, because this is kind of like really the core that the machine, whatever operation the machine is performing, at the end of that operation, you want to be able to collect all of that information and push it out. So this is kind of like the basic unit of information that you're then going to use for many different use cases, whether it's for asset reliability, quality. So as you could see here, we've got a namespace for collecting cycle data about that specific piece of equipment. And here you can see that we've got cycle time. When did that cycle start? When did that end? How long did it take? What's the shift? What is the total time of stamping? What was the energy consumed? What was the inspection result? So at the end of each cycle, this is the critical information that you want to be able to collect, so that you can then use that information for all these different use cases that you want to be able to perform. And then you also have got a namespace for the kind of like the job parameter. So kind of like during the execution of that batch, or during the execution of that specific job, are there some continuous parameters that you want to be tracking throughout that process? So this is not kind of like cycle data that you get at the end. This is the data that you kind of like get. This is telemetry data. This is kind of like that metric that you get as and when that specific piece of equipment is being is working on a part. So again, as you see, the job cycle and the parameters are those elements, those basic units that you'll then be able to use later on at a higher level. Maybe you're building a digital twin. You want to be able to sort of like aggregate to say, this is a piece of equipment. This is the current state of this piece of equipment. These are the current operational state. These are the current parameters. These are the cycles that have been performed for this specific shift, or these are the cycles that have been performed for the last month. You're kind of like creating this digital twin or digital thread from these basic information that you've sort of like carefully put as namespaces within your unified namespace. Or it could be for OEE calculation, again, as we'll show you later. And then we've got a defect. Obviously, this machine might sort of like produce defect with parts. You want to get those defects out as an event to say we've got a defect. Again, this is the information that you use to calculate your OEE and all these other asset reliability metrics, and also downtime. Again, as you notice, this is information that is related to the piece of equipment. You want to create a namespace for your downtime. And then you've got alarms. You want to create a namespace for specific to a job, or you want to create namespace that is just specific to a piece of equipment. So as you can see here, we've kind of like built a namespace under our equipment or under our resources, whose job is really kind of like to reflect the current state of your equipment, right? And then you could then use all of that information for the different use cases. And this kind of like your use case may not exactly be the same like this, but it's kind of like to give an idea that you need to determine a namespaces for when information is going to be triggered, like when the events are going to be triggered. And for this specific example, these are the namespaces when information is going to be triggered, whether it's the end of a batch, the change of a parameter, it's a change of state, whatever the case may be, that information is passed on or is pushed out as an event through that namespace. So whatever application is interested to find out the current state and the cycle information, typically you want to persist your cycle information into a database. So maybe it could be a relational database. So if you've got like a HiveMQ broker that is has got this namespace. You can use an extension to subscribe to this specific namespace and persist all of this cycle data as it comes through, or you want to persist all of the downtime data as it comes through to whatever database or whatever application you want to be able to do. So again, here it is this idea of sharing information. So as you will see, as we move on to the next step on exactly how all of that information is being exchanged. So as you notice, it's process events plus machine events that you are defining here. So let's move on to the next step. So the next step here is now, so again, if you notice here, we defined information that reflects the current state, the operational event, the current state of exactly what's happening. We're producing stuff, we're producing doors, in this case here, car doors in this case here, and then we've got these events that we're reporting. But now you want then to be able to then start to look at namespaces that are more use case specific. Now you kind of like now are intentional about how you want to use that data. You're no longer just getting information, the basic unit that you need to aggregate at a later stage, but now you're kind of like looking at a use case to say, okay, I want to perform predictive maintenance for this specific piece of equipment. This is where you then start to create namespaces that are use case specific. And this is kind of also a big shift that I see a lot of companies making the mistake where they're kind of like just focusing or looking at a unified namespace rather as a medium for just transporting data and then worrying about use case later. You want to be able to build data products for your use cases at the edge by the automation engineer, by the process engineer, by the domain experts, because they know exactly what are the different pieces of information that are necessary, or what is it that is important to measure, and which kind of like reminds me of an interesting sort of like anecdote where a data scientist kind of like collected information about a compressor, and the insight that they came up with was how a compressor works, right? And this is not useful information because that is already known in the OT domain, that this is how a compressor works. This is physics, right? So there is that domain expertise is very important, kind of like really determining exactly what is realistic or what information needs to be shared, and then create that information, and then it is passed over. So it's a collaborative effort between the data scientist or the IT and the OT sitting down together, at least with some of the customers that we've worked with, where the OT and the IT, they sit together and then they kind of like decide, okay, we want to perform predictive maintenance on this piece of equipment. As a data scientist, these are the parameters that I need. As an OT engineer, this is basically how I think this information to be presented to you, or these are the data points that I can get hold of, and I know precisely where to get that information. That one is coming from an Opus UA server, that one is coming from a Modbus indicator, that one is coming from all these different sources. You want to be able to contextualize it at the edge and then share that information through that namespace, which is a use case specific namespace. So I'll quickly show you a predictive maintenance namespace. So as you could see here, this is sort of like, again, an oversimplified predictive maintenance data product, just to kind of like demonstrate the concept here. But here you notice that we kind of like just collecting information about this specific mechanical press, and then for the sole purpose of consumption by a predictive or prediction model, and then we're creating a namespace for it under that specific piece of equipment, and then we're pushing that data out. And then here we've got a namespace that kind of like just for collecting asset performance. And this is specific for asset reliability information. So as you could see here, we've created a namespace where we're collecting data like production count, right? How much stuff has been collected. This is the scrap count, right? So again, this is the information that is from wherever it is originating, whether it's coming back from MES, where it has been collected. So you have an MES system that is sort of like subscribing to receive defect information or cycle data about what's defective or not, and then doing the aggregation and then pushing that information back down to say, this is the production count, and then this kind of like information that can be consumed by anyone who's interested in accessing that information. And this is also a very interesting point to make here. Again, what I see a lot of sort of like customers making a mistake of kind of like thinking of this as say, well, but why would you want to build a use case inside the unified namespace? The use case needs to live outside the unified namespace. And that kind of like thinking is flawed in the sense that you are assuming that only that person who's building that use case is going to need that information. That information may be needed by supply chain. That information may be needed by shipping, hypothetically speaking, right? So the idea of transparency and putting information where it makes sense for anyone who's looking for that kind of information to find whenever they need it. So whenever a situation arises, you are a supply chain sort of like expert and you're looking for a certain piece of information, you can navigate your unified namespace semantically and look for the information that you need and then find that information without necessarily needing to know beforehand where that information is, right? So again, this information is being used to calculate things. So you've got your scrap count, schedule time, operating time, all these sort of like elements that you need to be able to calculate availability, quality, and performance. Once you've calculated availability, quality, and performance from that, you also want to be able to calculate your OEE. You also want to calculate your MTTR. You want to calculate your mean time between failures and all these asset performance metrics. So as you could see now, we're shifting from kind of like more current state reflection to more use case specific, where kind of like being intentional about how we are packaging this information and putting it into namespaces where it can then be consumed by whoever is interested in finding that information. So here, again, if you kind of like think back to the sort of like architecture that I showed you, where you've got these different user roles. So you're kind of like thinking about a maintenance manager. What information would a maintenance manager need? Or a maintenance manager could make a request to say, this is the information that I need. And then a namespace could then be built specifically for the consumption by the maintenance manager, production manager, or a process engineer, or a quality manager, predictive maintenance, whatever the case may be. You are thinking about the user first, and then working your way back into the unified namespace and creating that information there. Okay, so that is that on the use case specific information. So let's move on to the next. Okay, so what I'm going to talk to you about next is then to say, again, the unified namespace is kind of like this common data infrastructure, as I mentioned, business and IT, business and control, where kind of like a sharing information. And one of the most important things that you want to be able to do is to bring information down from business or from IT into your shop floor. So kind of like the idea here now with this unified namespace is you want to be able to describe the main kind of like transactional interfaces between your ERP system, for example, and the control domain. So an example, say maybe a client as kind of like as put an order, and that order is now in the ERP system. Now, typically that order, well, I've worked in places where that order is kind of like printed out in a piece of paper. That paper is taken into production. Production then goes to logistic to confirm that we do have availability of equipment and material and so on and so forth, right? So you want to create a namespace to be able to kind of like automate that and kind of like decouple that from having a situation whereby an ERP system, in the case where an ERP system is directly integrated with MES system, it's a tight coupling where the implementation details of the MES system and the ERP system are very important. As soon as you remove the MES system and replace it with another one, everything changes on the ERP side in exactly how you save that information. But the unified namespace, through that namespace, allows you to say, we're just kind of like sharing that information irrespective of who or what system wants to kind of like access that information. So for this specific information here, we've created an ERP namespaces in our production line area here. So in ERP namespace, basically here now what we're doing is we're kind of like sharing information into the control domain from the business domain through the unified namespace. And kind of like this is also one of the questions that I also kind of like get a lot to say, how do we sort of like, how does the unified namespace replace the ISA 95, right? So the unified namespace still preserves the principles of ISA 95, but it's no longer a pyramid. It's now a network structured architecture. So as you will notice here, this is an implementation of ISA 95 Part 2 activity models, right? All these activity models that were defined on exactly how you should exchange information between ERP or business and your control system. So here, one example is an operation schedule. Typically, you want to exchange your operation schedule with your control domain. You want to pass that information about your operations request. So we've created an ERP namespace. We created under that ERP namespace, we've created a namespace for operation schedule. We also have got an operations definition, which is kind of like the information that then gives us to say, on this specific production line, these are the parts that are being met, kind of like defining the operations. And then here we've got operations requests, right? And then again, typically, when you move information from IT into shop floor, you want to move production-related information. So it could be a production order, maintenance-related information, the maintenance request, it's an inventory request, or it's a quality request, or whatever request is coming from your shop floor. You created a namespace for it here. So here you could see an example. I've got a production order here. This is information about your production order that is coming from ERP. Now, an MES system, because it knows that it needs to monitor production orders that are being published as events into the unified namespace, would then subscribe to this specific namespace. And it would know, okay, now I need to go into ERP, operation schedule, operation requests. I'm now subscribed to receive production requests, maintenance requests, inventory requests, and then go on to execute on those. So you're defining a namespace for interchange or this exchange model of information between your enterprise and your business rather, and your control domain. So again, here you see we've got information about your control related data. So again, what I want to sort of like focus on next year is let's see. Let's move on to the next one. So we've sort of moved your operation schedule, your operations request into the control domain. And typically, what you want to do, you want to send responses. So you've put out a production order. You want to get a response on what is the response on that request that has been sent. So again, I've worked in places where paper-based communication is used, where once a production has been done, that information is gathered, it is pushed back into IT to say this is what has been done, or this maintenance request has been fulfilled, and all those details about those activities that went on. So you want to be able to create, again, a namespace for sending information back up again into the ERP or the business domain. So I'm generally using ERP here for the business level. So you may have a lot of business applications that want to interchange information with your control domain, but for purposes of demonstration, we're going to focus on the ERP system in this case. So let me then quickly show you how then you are then able to send those responses back into your business domain. So again, as you notice here, it's sharing information. It's not collection of information as it were. You're sharing information. Granted, you're going to persist all of this information, as I mentioned. Some of it is going to end up in a data lake because you're going to need historical context when you analyze this information later on. So all of this information is going to be persisted in a database, in a data lake, in a data warehouse. But the unified namespace really is a way where that allows you to share of this information in real time, putting information in the hands of the people that need that information. And if you think about it, besides unified namespace, or the other way of really doing it, you have to sort of like submit a request to a central data team to say, I need information about this specific KPI, or I need this. And sometimes that will take days, right? Rather, or weeks just to get that request fulfilled, because you've got a central data team that is handling all related or data related queries. And then but you want to be able to get this information in real time. So setting up these namespaces beforehand and kind of like really kind of like setting up this exchange model. Exactly, this is how information is going to be exchanged here. You're putting information, real-time information, in the hands of the people that need it. Whenever a new prediction has been determined, it is pushed into the unified namespace. Whenever a process engineer wants to find out what's the latest prediction on this machine or on this, they simply just kind of like need to get that latest event. So information is always in the hands of the people that need it. And this also encourages citizen developers, because now working with data, working with information is no longer kind of like the purview of specialists, right? It's people, anyone who's a generalist can work with data, whether it's a machine operator, they can kind of like create whatever dashboards and then publish that information. It ends up in the unified namespace. They can consume information. A process engineer can consume information. So I kind of like just want to reinforce that idea of sharing information rather than sort of like collecting. Sure, there's collection element to it. So here, we're now kind of like have an operations performance. So as I mentioned, again, you've got requests coming from OT, from IT into OT. Now you want to send those performance information back up again, right? So again, as you notice, you are slowly building up this automation of a business, because eventually as these orders come in and all these processes are being executed, this automation of information is being kind of like really you're creating a potential for business automation within the unified namespace itself. And obviously with the advent of automated things like AI agents and things like that, you can imagine kind of like setting up a foundation where you're then able to have this coordination happening autonomously between trusted parties. Obviously, if once you get to a stage where you are kind of like have some trusted AI agents, but this is what it's all about. It's about automating your business process, right? Kind of like getting that efficiency. So here you can see we've got responses to all these production-related requests that we received earlier. So here I'm responding to a specific production order that came in, right? And then here I'm responding to specific maintenance requests that came in. So you're specifying this task was specified. This is the downtime that was resulted off of that. And then here, if you go into production order, you could see that this is the information that is saying, okay, we did actually execute this order. Quantity scheduled was 245, but we actually produced 250, but we actually produced 245, and then there's reasons for that. So kind of like these performance-related information that is still going on currently in manufacturing, but a lot of it is manual, a lot of it is kind of like tightly coupled, a lot of it exists in these siloed systems, but now we are using the unified names as this open ecosystem where systems don't kind of like, they share information without a care on exactly how it is consumed, or rather exactly who or what implementation details are needed for consuming it on the other end. You are creating your namespace as the ERP system and saying, I'm the ERP system, these are the maintenance, or these are the operations requests that I need executed. I don't care if you're MES system 1, or you're sort of MES system that only understands OPC UA, or you're an MES system that understands a REST API. We are all communicating through this common data infrastructure. There's this decoupled element to it. So there's reusability of parts also in that specific instance. So so I've spoken about the idea kind of like of sending back this operations performance. So now what I want to talk about is the manufacturing operations management. So again, we spoke about this idea that business, in most cases, they will send a production order, or kind of like maybe a production or operation schedule to say we need 500 chairs made. Well, they don't really care whether you're going to make 25 here or 25 there. You know, this is the work of kind of like the manufacturing operations management. So you've got exchange of information that is then going on within the control domain, where you're kind of like saying, okay, we're going to make 20 of these there, 15 of these there. So again, this is where you're going to use the unified namespace to coordinate that exchange of information, again, through the unified namespace. So as you could see here now, we've got a work schedule namespace, kind of like we're now scheduling all of these work requests, right? So different systems are going to be coordinating through these namespaces about what sort of like work requests. So as you can see here, we've got different work requests that have been published here. And then again, we're also going to have work performance. If a certain piece of work or job has been completed at a certain work cell, you kind of like want to get sort of like feedback to say this work has been executed. This is a work response, and then that information is published again through the unified namespace. So again, going back to my point, you're exchanging information. You're exchanging information. Information may end up in a persisted format, but this is the kind of like the first integration point of all your data, right? Contextualized, high quality data such that when you then persist it, there's no more kind of like data engineering that kind of like needs to go into it. So this is kind of like also a very productive way of working with data. And also here, what you will notice is that you've also got KPIs. So these KPIs is, if you remember, we had a KPI or asset performance namespace for each machine at each work cell. So you want to be able to aggregate all of that information to production line level, right? So you're kind of like a line manager, or maybe you kind of like just want to reflect that information at an enterprise level to see this is exactly how that line is performing. So what you see here is a namespace of aggregated OEE, or in kind of like MTTR sort of a KPIs. You're aggregating all of that information. You're aggregating availability of all your pieces of equipment in that specific production line. And then you're also kind of like aggregating performance and all these different systems. So you've got a kind of like a namespace here under your MES. And then this may kind of like be consumed by, say, a production manager. They're building a dashboard where they're using Node-RED, you're using a SCADA system, a web application, or it could be a production management system, right, that allows you to build this dashboard. But for you to access that information, you kind of like simply just subscribe to get these KPIs from this specific production line. And if you want to subscribe from multiple production lines, you can then use sort of like the wildcards within MQTT to then say, I need all KPIs from all production lines, or I need all KPIs from all work cells, and so on and so forth. So you kind of like really sort of like raising your hand and say, hey, I need this information, and then that information will be shared to you through the unified namespace. So the last thing that I want to talk about, so that we can open up for the Q&A, is the ability to also share. So there's just so much that you could share. The point is kind of like share the best practices on exactly how to structure your unified names, how to design your namespaces. But there's just so much that you could share through this namespace. But the last point that I want to show you here is kind of like sharing the operations capability, right? Because again, you might kind of like remember that this is about automating your business process at the end of the day, right? And you want to be able to kind of like also advertise your operations capability, which again is stuff that is being done worldwide by manufacturers, where you know your operations capability. At any given moment, you want to know what's my capacity, how much can I make? I've got an order that says I need 1,000 chairs or 1,000 doors, but how much can I make, right? That information then is then available on the unified namespace. You're always subscribed to know at any given moment what is my capacity. So here you could see I've got a namespace under this specific process segment. It may not exist in this segment. It may exist in a work cell line, depending on exactly what you approach as an organization. But here you can see that I've got operations capacity, which may be a theoretical capacity to say this is so much equipment that we have, so this is so much that we could do. But the available capacity may be different, because then maybe some pieces of equipment are not working, some are being maintained. So you want to have an available capacity all the time. So here I can then see what is my available capacity, what sort of equipment is available to me right now. That information is in the unified namespace. I can subscribe to it and get it whenever I need to. So if I'm a scheduler, I need all of this information. I don't need to create a standing connection with the MES system or whatever system is giving me this information, or whether it's a paper-based. I just need to subscribe through this abstraction and get all of this information, right? And then I've got a committed capacity again. So say from this available capacity, how much has already been committed. So this is coming from an operations perspective, but you also could get a capacity from a work capability from like a work perspective. So based on the work that needs to be done on the control level, how much capacity do we have? How much capacity is available? How much capacity is committed? And how much capacity is there theoretical for whatever reasons, kind of like we may need that information. So as you may see, kind of these are concepts that mostly are found in your ISA 95 Part 1, Part 2, Part 3, and Part 4, right? And kind of like really being used in the unified namespace, because the idea is to say this is not a hard and fast rule. Again, I need to kind of like reiterate that, but a lot of work has been done, a lot of kind of like thought has gone into analyzing what are the common ways of exchanging information in manufacturing operations. And then this is kind of like a result of 20 years worth of work to say these are the typical objects that are exchanged in the manufacturing enterprise, and then they were standardized on. So now we're kind of like just taking that inspiration and implementing it in the unified namespace with no still kind of like without being tied to a specific technology. It's all common data infrastructure. Everything is being accessed through your common MQTT broker. So that kind of like brings us to the end of this presentation, and I think we've got 5 minutes left here. So maybe let's see if we've got some questions. So we do have some questions. Okay. So we've got a question from Newton. So is an MQTT broker per se a unified namespace? What are the main and mandatory components of a unified namespace? So the MQTT broker is so kind of like the definition of a unified namespace may vary, but rather from the definition of saying your first integration point, kind of like that place where you go to find the latest information is your MQTT broker, and your MQTT broker is your unified namespace. You may persist that information elsewhere. There may be a historian elsewhere, but that is kind of like not the first integration point. So your unified namespace is your MQTT broker, but you may want to access information elsewhere and bring it into the MQTT broker. For example, there's a historian that has got historical information. Because your MQTT broker doesn't give historical information, you can perform an ad hoc request from a historian, get that data out, perform whatever information you want to perform. But if it's a common request, you might want to package that into a namespace and push it into the unified namespace so that it lives there. And anyone who may have a similar request as you will then find that information there. So unified namespace is your MQTT broker, and it's kind of like your first integration point. Okay, so I've got a question from Peter. What is your advice on putting a timestamp in each JSON for time series data? So here, if for putting the timestamp, you want to have a timestamp for when each metric was collected. Because remember, let's say you've got your cycle data, you've collected data from a quality system, from a Siemens PLC, from an indicator. This information is being collected at different times. So you want to get the metric or the timestamp for each metric, and then you want to have a kind of like a metric for when that information was pushed out as an object. So you've got two levels of your timestamp: collection time and publishing time. So maybe you want to look at Sparkplug to get a sort of like an inspiration on exactly how to structure your sort of like timestamp, because that's the exact principle that Sparkplug follows. So why call press shop area and not the actual area ID or area name? So so that's actually the area that's the name of the area in this specific instance. It's the press shop area, and again, this is also it's a design sort of like approach to say you want to kind of like specify this is an area, this is a line. So you don't want to sort of like name things generically. So you may know that maybe within an organization, but for ease of access or for ease of discovery of information, you want to say door press line or production line to say to indicate that this is a line, or press shop to indicate that this is the area, or work cell. You want to always have that cell. Again, it's not hard and fast rule, but it's the best practice for easy discoverability of information for whoever is navigating that namespace. So we've said, is there graphical user interface for entering UNS data? Can we present in a graphical diagram? So, I mean, as long as whatever platform consumes information, so maybe you want to use a historian, you want to use Node-RED, you want to use a custom build tool. So it doesn't really matter from a UNS perspective, you can get all of that UNS data. Okay, well, let's see. Is it possible to get access to a test broker view only? Okay. Well, send us an email or a message, Lars, and then we can see what we can do that. I'm sure we can organize something for you. How can we govern USNS data to ensure that what is present in UNS matches the entities that exist in the real world? Not sure I understand your question. But a big part of the unified namespace is like all of the stuff that I showed here is going to be a specification that you need to agree on before you move on into implementation. You're going to come up with your UNS specification for your organization to say, this is how we're going to lay things out. So this is kind of like the enforcement of saying this is how these things are going to be laid out. And then you can maybe do some enforcement within the broker itself, where then kind of like putting some security measures to say a role-based access control to say you're only able to publish on this particular namespace if you are this client ID and all things like that. Okay, it seems like we've run out of time. There's still more questions to answer here, but if we certainly be happy to follow up with you on all of these questions. So thank you so much again for taking the time to join us today. I really appreciate it.